This is a video for Dividing Fraction Review 2. So again, make sure that you check your answers. If you want to fast forward to where you can see the answers and then only rewind if you need help, you can do that. Or if you want to go through them with me, you are welcome to do it along with me and do the strategies with me. Okay, good job, Harper. Okay, so I see here that I need to divide two fractions. There's no context with this problem, so it's not easy for me to draw a model. I know that I'm taking 1/8 and trying to decide how many 2/5 are in 1/8. That doesn't have good units with them. I could try to unitize them, or in this case, I would just go with the algorithm. So I need to divide. Please don't cry. Just flip the second fraction and multiply. I would then check to see if I can cross cancel anything. I don't see 1 or 2 don't have any common factors that I can use. 8 and 5 don't have any common factors, so I just need to do a numerator times a numerator, which 1 times 5 is 5, 8 times 2 is 16. So the answer is there is 5/16 of a 2/5 in 1/8. Looking at the next one, 8/9 divided into 5 equal pieces. Again, I could draw a model of 8/9 and then try to break it evenly into 5 pieces, but I know I have 8 pieces. That's not going to be easy to divide by 5. So I'm going to go ahead and use the algorithm for this. Need to divide a fraction by a fraction. So first thing I need to do is make sure that this is a fraction. So I'm going to rewrite it over here. 8/9 divided by 5/1. When you have a whole number, you put it over 1 because you have 5 of them and it's cut into one big piece. So need to divide. Please don't cry. Just flip the second fraction. Remember, you should be really good at this saying by now. If you're not, you need to do some more dividing fraction problems and you could make them yourself. Just put any fraction divided by any fraction. Then do it as you say it. Need to divide. Please don't cry. Just flip the second fraction and multiply. So I bring this straight down. Again, nothing to cross cancel here. We have 1 and 9, 8 and 5. They don't have any common factors. So 8 times 1 is 8. 9 times 5 is 45. 8/45. This is another case where you should have these basic facts down. If you don't, Number November is for you. You need to be using extra math and some other activities like that to get these basic facts down so that you can do these problems no sweat. All right, next we have 1/3 divided by 2/5. So again, no common unitizing here. I could change them both to 15ths, but it would just be simpler or as easy to go ahead and use the algorithm. Need to divide a fraction by a fraction. Please don't cry. You know the action. Just flip the second fraction and multiply. Again, I check for cross-canceling options. 1 and 2 don't cancel. 3 and 5 don't cancel. So then I do 1 times 5 is 5. 3 times 2 is 6. I know that anytime I have a numerator 1 away from the denominator that they're not going to have any common factors, so that is as simple as it can get. So next I have 3 and 3/8 and I need to divide it into groups of 2 and 1/4. So first thing I want to do is do it fraction divided by fraction. So when I think of 3/8, I think of 3 wholes. So if I had 3 whole candy bars and a little bit of another one, because that's what this fraction piece is, and it says it's cut into 8ths. So I'm going to cut them into 4ths this way and then just cut them in half like that. So now I have 8 pieces. So I have all of these, all of these, all of these, and 3 more of this one. So I notice I have 3 groups of 8 pieces. 3 groups of 8 pieces is 24. That's where I get that 3 times 8, plus I have 3 more pieces here. So if I had 24 pieces plus 3 more, I now have 27 pieces. What size are those pieces? They're all 8ths. So I have 27 8ths, and then I have 2 1/4. So again, if I have 2 wholes and 1/4 of another, how many fourths do I have? Well, I have 2 groups of 8 pieces, which is 8 pieces. That's where I get the 2 times 8, plus 1 more piece. That's 9 fourths. So I have 27 eighths, and I'm trying to break them into 9 fourths. I noticed that I could unitize fourths into eighths, so I could do 9 fourths is the same as times 2 times 2. I have 18 eighths. So in 27, how many 18ths do I have? I would only have 1. So now I'm going to do a number bond here. 1 group of 18. So it's 18, and what other number gets me to 27? Well, 18 plus 10 would be 28, sorry. It's late at night. That would be 28. That's too much. I don't need 27. I just need 9. So I have 1 whole group of 18 and then 9 18ths of another one. So that tells me I have 1 and 9 18ths. I know that 9 18ths, 9 is half of 18ths, so that equals 1 1/2. Or I can do the algorithm here. I can do need to divide, please don't cry. Just flip the second fraction and multiply. So here I have an opportunity to cross cancel. I notice 8 and 4 are both factors of 4, so 4 divided by 4 is 1. I always like when I get a 1 because I know it's easy to multiply. 8 divided by 4 is 2. I also notice, because I'm so good at my basic facts, that 27 and 9 can both be divided by 9. So 9 divided by 9 is 1. 27 divided by 9 is 3. So now I have 3 times 1. 3, 2 times 1, 2. So 3 halves, that's an improper fraction. So I need to figure out how many groups I can pull out of that. 3 does not divide by 2, but what number hiding in 3 does divide by 2? How about 2? 2 and 1. So 2 divided by 2 is 1. 1 divided by 2 is 1/2. Still the same answer. Either method is fine as long as you can get to the correct answer. All right, here I have 4 1/2 divided by 2 7/10. So I remember from my pictures over here, oh yeah, when I have the whole number, I have that many groups of this pieces. So 4 times 2 is 8, plus 1 more piece. That's 9 halves divided by 2 times 10 is 20, plus 7 more, 27 tenths. So this is another one that I could change this to tenths and try to unitize it. I think it might be easier just to go ahead and use the algorithm, because I'm going to get into some big numbers here. So if I just do need to divide a fraction by a fraction, please don't cry. Just flip the second fraction and multiply. So again, I want to cross cancel because these are going to be super big numbers. Anytime I have these big numbers here, there's a good possibility that they might have a common factor. So 9 and 27, again, I can divide those by 9. So 9 divided by 9 is 1. 27 divided by 9 is 3. 2 and 10 are both even, so I can divide those by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. 1 times 5, 5. 1 times 3, 3. Again, I notice it's improper, so I can't divide 5 by 3. What number hiding in 5 can I divide by 3? How about 3, which would leave my other number to be 2. So I have 3 divided by 3 is 1. And then I have 2 divided by 3, which I can't do, so I will do 2, I can't do it easily, 2 divided by 3. So my answer is 1 2/3. 7 1/2 divided into 1/4. 7 times 2 is 14, plus 1 more is 15 halves. Divided by, have to make it a fraction divided by a fraction. Fractions really only play well with each other, so they don't like mixed numbers or whole numbers, so we have to make them all fractions. So 15 divided by 2, 15 halves divided into 1 times 4 is 4, plus 1 is 5. So we have 5/4. This one might not be a bad one to unitize and just do it out of fourths. So if I wanted to change 15 halves to be out of fourths, I would have times 2 times 2, so that would be 30/4. So if I have 30/4 divided into groups of 5/4, that means I would have 6, because 30 divided by 5 is 6. Just like if you had 30 ducks divided into groups of 5 ducks, how many would be in each group? 6. 30 dogs divided into groups of 5 dogs, how many dogs would you have in each group? 6. 30/4 divided into 5/4 means that I could circle 6 of them. If you're not comfortable with the unitizing version, that's okay. We can do the algorithm as well. 15 halves divided by 5/4. Need to divide? Please don't cry. Just flip the second fraction and multiply. Do you want to say hi to my friends? Okay. Oh, you're sideways. There she is. Can you say hi, friends?
Hi, friends.
Say, are you doing your math?
I do your math.
Say, my mom's the best.
My mom's the best.
Good job. What do you want?
I don't know.
Oh, okay. I'm going to go back to my video, okay?
Okay.
Say bye.
Bye.
Sorry, these are the difficulties of doing our videos at home. Okay, so if you needed to do the algorithm, we flip the second fraction and multiply. I see across from each other, I could divide both of these by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. Yay! 2 and 4 are both even. I could divide them both by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So then we have 3 times 2 is 6. 1 times 1 is 1. We know any number over 1 is a whole number of 6. Same answer I got when I unitized. So some people might find this way easier. Some people might enjoy this way. We just want to make sure we have plenty of options and tools in our tool belts. All right. I'm going to go ahead and cut this video off, and I will do the back end video too.